guys, so welcome back to my easy session of explanation regarding the structures. We had everyone had a great break and everything is going well. So without further ado, let's get started with a very fun, interesting fact. So in this session we'll be covering 5 important topics: introduction, effect, example, and how it relates to it. Yeah. The topic is this is very crucial for everyone to understand. Previously I already explained what is a moment. Just to recap, a moment is actually a force that's caused by the after effects of an action that has been applied to it. I should say this is more of an action effect. An action effect caused by the force. And it is called a moment because it is at that point where the effect is coming into play. So if this is my being and it's being forced here, this point is moment and it's gonna decapitate it downwards. So it's bringing it downwards. Bending moment is important to know because when some force is being applied onto it, the resistance the beam that produces, the effect that comes into play, that effect is called as bending moment. Moment is the force, effect is the bending moment. Its SI unit is kilonewton meter. SI unit is a good way, it's called the System International. It's a good way of understanding what is what. The units, the SI units itself is self-explanatory of what it is. So that is bending moment. An example, I have this beam that's being simply supported. The moment the force is being applied downwards, the beam needs to resist upwards. So if I show it like this, it's going downwards, it's being sagged up, and now it's needs to come back. So this is known as bending moment. If I show you with this example, it's a very common way to produce. This is a homogeneous material. It's a tweed. It has a capacity to sustain certain amount of forces. Watch. I'm going to apply a force here. I'm applying. You can see it's getting elongated. It's beginning to bend. I'm increasing the force. It's increasing to bend. It's going to be, I can hear the sound. The member's capacity was reached. The force reached the member's capacity, and so it broke. This is the effects of bending moment and why it is important to make sure that it doesn't affect it, because this beam, it's resisting as well. It's preventing it from bending, but I'm keep on increasing. So there's a limit where it cannot go up to that point. So this is why it's snapped. Another phenomenon to note is bending moment depends upon your supports. My hinge, if you remember my previous fixed roller. So the reactions that are being found here these reactions define the end support. What is going to happen at end supports? Wherever you apply the load, wherever it is, the action effects come into play. So that's that. I've explained with a scenario. I've explained with an example. I've explained with a concept. The unit goes like this. I'm applying a UDL. A UDL stands for uniformly distributed load onto a beam. If, this is a fun fact, if something that's falling onto the beam, perpendicular to the beam, these are known as transverse forces. Something that's going parallel to it, these are known as axial forces. These come more into play when we do columns and post design, because post is going to be standing straight and the force is going to fall onwards. So this is known as axial force. Beams are more dominant in the not dominant, more into calculations for transverse force. So there are two kinds of categories. One is a UDL, one is a point load. Remember, the SI unit was kilonewton meter. This is my meter. This is the kilonewton. This is my meter. This is kilonewton per meter. Because at every point there is the force that comes into play, so it's like affecting the whole scenario, the whole beam of it, not just the location. Now, if it's a point load, which is this scenario, I'm thinking of first of this scenario. At this point, my bending moment will be the highest, because remember, wherever the force is applied, there's going to be a moment. With force comes a moment. So that's that. The formulas come into play for this. Usually for a point load, is denominated by P, which is known as point load. UDL is denoted by W. It's considers into the effective load width, or I should say the tributary area, the terminology, the right terminology. Both terminologies are important. The width, the load width is more of a basic understanding. The most advanced concept is way to say is called the tributary area, or somewhere it's called as tributary area. The point load gives me a bending moment of P by 4. P by 4 is the shear force, and then it comes as PL by 8. Because remember, P is the force, that's kilonewton, and is being multiplied by meter. So it becomes as PL by 8. Similarly, if I go for a UDL, remember a UDL is being denoted. I'll show this at a different time. Kilonewton per meter. So I need to bring this down to moments SI unit, which is kilonewton meter. So remember what I told you? The load multiplied by the linear meter divided by 8. So kilonewton is multiplied by meter. Okay? We say that it's being multiplied double the meter. So in order to bring it down to kilonewton meter, we need to multiply it by 2 times of its length. Therefore, this becomes as WL square by 8, which if you work out, if I put it like this, this gives me WL square by 8. So that means this is kilonewton per meter multiplied by meter square by 8. Meter square, meter get cancelled, so that becomes as kilonewton meter. And obviously 8 is the factor that's being divided upon. So this is that. So this phenomena, this amazing, interesting fact is bending moment. Bending moment is more of a bending stress, the stress that it's suffering because of the load. In conclusion, bending moment is an action effect that comes into play when a force has been applied. So I hope the session was interesting. I'm will be keeping it short, and I do hope that you all enjoy your Sunday. Have an amazing day, and I will see you in the next sessions. Oh, and by the way, if you have any questions, please Q&A will be available, and you can also comment on my video. Any questions you have, I'll give my best to answer. Peace out.